Now let us convert decimal number into hexadecimal. For example, 78.8, this decimal number has to be converted into hexadecimal. What the method we have implemented in conversion of decimal number into binary, the same method we have to convert here, use here. We have to solve integral part separate and fractional part separate. The decimal to binary conversion method was called as double method. Here this method is called as hexadecimal method. Here the integral part is solved like this. Suppose the integer in the example is 78. So we have to take 78 here. We have to divide it by hexadecimal number. So that is why the base of hexadecimal number system is 16. So we have to divide it by 16. So 16 fours are found to be 64. So 78 minus 64, the remainder will be 14. So 14 is noted here. Again, this quotient has to be divided by again 16, but 16 is greater than this quotient. So that is why this less number has to be written as it is. Just what we have done in conversion of decimal to binary. So here 4 is written as it is. So this number has to be right in upward direction. Now here to represent the hexadecimal number system, the hexadecimal number system and decimal number system is very same, that from the digit 0 to 9 they are represented as it is in the hexadecimal number system, and after 9, that is 10 to 15, they are represented by the alphabets from A to F. So if here instead of writing 14, the last number is 15 and 14 is equivalent in decimal, hexadecimal will be E. So that is why I will write here 4 first, and the hexadecimal symbol for 14 will be E. So here 78 in hexadecimal will be 4E. Now going to fractional part. Here the fraction is only 0.8. So here only point is 8 is taken. We have to multiply it by 60. The answer will be 2.08. Here again we have to note the integer. Now remaining fraction, it should be again multiplied by 16. Answer will be 1.28. 1 will be the integer. It is noted here. Again 0.28 is the fraction. It has to be multiplied by 16. The answer is 4.48. Here the 4 is again noted here. Then after again 0.4 is 48 is multiplied by 16. 7.68 is the answer. So here integer it will be 7. 7 is noted here. Again 0.68 is taken and it is again multiplied by 16. The answer found to be 10.88. So here 2, 1, 4, 7 and 10. This will be the fractional parts conversion. Here 2 will be written as it is. 1 will be written as it is. 4 will be written as it is, and 7 will be written as it is. But instead of A, instead of 10, we have to write A here. So here the hexadecimal conversion of 0.8 is found to be 2147A in hexadecimal. So this is how we can simplify the fractional part. Now moving reverse conversion. Suppose a hexadecimal number is given 4E.A7 and it has to be converted into decimal. Then here we have to write in the same form. Then unit places of 8 digit has to be mentioned here. Then same done in binary to decimal. Same thing is done here. So E, that is 14. So 14 multiplied by hexadecimal unit place, that is 16 raised to the power 0. So 14 multiplied by 16 raised to the power 0 plus 4 multiplied by 16 raised to the power 1. So these are the unit places in hexadecimal numbers, and they has to be multiplied with these bits, and their multiplication has to be added. So here 16 raised to the power 1 is 64, and 64 is written here. Then plus 14 multiplied by 16 raised to the power 0, that is 1. So answer will be 14. So 14 plus 64 found to be 78. So here 4E is equivalent to 78 in decimal. So this is how integral part is solved. Now for the fractional part, The fraction is a point A7, so point A7 is written here. A's unit place will be 10 raised to power. A's value in hexadecimal will be 10. So 10 multiplied by 16 raised to power minus 1 plus 7. 7 multiplied by 16 raised to power minus 2. So here 10 by 16 we can write it 7 by 16 square. So here 10 by 16 is found to be 0.625 and 7 by 256. So the answer is 0.625 plus 0.027343. We can add a further after decimal point some name fractions also, but it will have more value. So neglecting the further, I have taken only 5 or 6 digits here. So here the addition of these two was found to be 0.65233. So in this way, point A7 in hexadecimal is found to be 0.652343 in hexadecimal. So here the complete answer will be 78.6523343 in hexadecimal. So this is how we can convert decimal numbers into hexadecimal and hexadecimal numbers into decimal.